A lot of people ask, what is EGAD? It's simple. EGAD is an instrument. The device beside me is EGAD, or the Energetic Gravitational Anomaly Detector. Anomalous observations in physics are the foundation on which scientific discovery is made, and EGAD was developed to investigate some of those mysteries. It was also created to probe for possible deviations of general relativity. One such mystery is known as the flyby anomaly. It is described as a discrepancy between current scientific models and the actual increase in velocity observed during planetary flyby of spacecraft. In multiple cases, spacecraft have been observed to gain greater speed than scientists had predicted, but thus far, no convincing explanation has been found. Another mystery is the measurement of excessive orbital velocities of stars in the outer bands of galaxies. Dark matter was theorized as a possible explanation, but modified theories of gravity could also explain the excessive star velocity.
In early 1972, mankind launched Pioneer 10, the first mission to the outer planets, the first to venture out beyond the orbit of Mars, out through the Jupiter.
Yet another mystery we hope to investigate is the Pioneer anomaly. The Pioneer probes, launched in 1973, are decelerating faster than the combination of gravity from the Sun and nearby planets can explain. Some investigations suggest it is possible that heat radiated from the craft applies a photonic deceleration, but the results are far from conclusive. Finally, the core of EGAD's design is inspired by a gap in experimental evidence verifying the curvature metric, which is the cause of gravity. This metric is associated with a rotating uniform rigid body, which is related to the Ehrenfest paradox. Discoveries revealed by EGAD experiments provocatively suggest that new frontier applications based on technologies that produce dynamic gravitational fields may be possible. We call this new branch of technology gravitronics.
Simply.
How can we consider EGAD's discoveries in an intuitive way? Consider the vibrations of a piano string. If we divide the piano string into individual segments of a length equivalent to the string's vibrating wavelength, and we consider that each segment's mass contributes to gravity, what happens to gravity when the string is vibrating? Does the gravitational field around the string vibrate as well? We don't know. That's one of the reasons, and there are others, it is so difficult to derive a unified field theory that joins Einstein's general relativity, the theory of the macro, with quantum field theory, the theory of the micro. The elementary particles, made up of electromagnetic, strong, and weak force fields, are experimentally verified and described by quantum field theory. Think electrons and quarks. Like the piano string, these particles are vibrating. But how is gravity responding? Unlike particles in quantum field theory, most astrophysical observations see gravity as a uniform, static field radiating from the energies of non-vibrating central masses. Other than recent confirmation of gravitational waves from colliding black holes and neutron stars, scientists have been unable to measure such small degrees of change in the gravitational field. However, Unspace has taken an approach with EGAD that we believe can infer a relationship between general relativity and quantum field theory, and in turn is hopeful that one day it can provide input into the derivation of a unified field theory. EGAD has the potential to help explore a new frontier of science. Though the practical opportunities are hard to predict, a unified field theory could unlock doors to new technologies. Much like quantum field theory and Einstein's theories of relativity led to transistors, GPS, radar, and optical lasers, in that same way, gravitronic technology could revolutionize communication, transportation, and even energy. Our immediate application goals include a resilient communication system based on gravitational waves. And beyond that, a novel method for the removal of space debris. But if history has taught us anything, when we unlock nature's mysteries, we are not only rewarded with new tools, but also a sense of awe and an inspiration to innovate. In the short term, the capability to generate and measure changing gravitational fields in the lab is a big leap. Physicists no longer need to wait for telescope availability and the unpredictability of astrophysical events in hopes of discovering new physics. After 3 years of research and development, EGAD has begun to shed light on some of the unexplained mysteries we discussed earlier. EGAD experimental results show that rapidly rotating and accelerating rigid bodies can generate measurable changing gravitational fields in the lab. By plugging the average angular velocity of the Sun into our new gravitational metric equations produced by the EGAD experiment, we can compute a gravitational coefficient that approximates the Pioneer deceleration anomaly. As we move forward, we will next turn our attention to the flyby anomaly and the anomalous velocities of galactic outer band stars. But most excitedly, we are very encouraged that early results suggest a relationship between the modified gravitational field produced by EGAD and electromagnetic forces of molecular binding energies. Such a relationship between these two forces of nature could be one of many steps on the way to a unified field theory. What's next for Unspace? We plan to submit a series of papers to journals for peer review. Meanwhile, we are hard at work creating EGAD 2.0 for continued scientific research and feasibility studies. We hope that one day these studies will lead Unspace and the scientific community to unlock nature's mysteries and a new frontier of innovative technologies.